Right, hi HPC. We're going to continue on with the idea of definite integrals. Those are ones, remember, that have an upper and a lower bound, so we're able to evaluate them without having to write a plus c. So this time we're going to ask you to set up the problem first and then evaluate it. So it's really just one extra step. And we put basically what to do over here. Now I just said it's one extra step and here's 4, right? But here's basically the idea. Let's take a look at our first example. And we have this curve right here has been created by this equation, y equals x squared plus 2x plus 1. So if I wanted to set up a definite integral to find it all that shaded section, all I need to do is realize that one of the sides is always going to be my x-axis, right? And then the other one is going to be the curve itself, right? So this is the curve itself, okay? So the first thing is that equation that I just circled is going to go into the integration symbol. So we're going to be doing the integration of x squared plus 2x plus 1, and we put a dx at the end of it. It's kind of like the period at the end of our sentence. We're basically saying we're integrating based on x. We don't have any other variable yet, but it's a good practice to get into. Starts with the integral symbol, ends with a dx. And then I need to figure out my upper and my lower bounds. So my upper and my lower bounds are going to be the lowest x value and the highest x value. So I'm going to see where that shaded in area starts and ends. So let's change that to a different color so we can see those better. So here is the lower bound. So the lower bound is going to be the -3. So we put that down here near the bottom of the integration. And then the upper bound looks like it's going to be up here near 1. So it is always in left to right order on a number line. Okay, and that's it. You got it set up. Now you just do what you've always been doing, which is integrate and then evaluate. So if I integrate this, this is going to be x to the third over 3 plus x squared plus x. And I'm going to evaluate it between 1 and -3. We put in the 1 first. So when I put in the 1, I'm going to have 1/3 plus 1 plus 1. And then I'm going to subtract out the other one, which is going to be -27 over 3 plus 9 minus 3. So let's see what this works out to be. So this will be 2 1/3. And then we're going to subtract out, let's see, we have a -9 and a +9. So that's going to be subtract out a 3, a -3. That's going to be like a +3. So this is going to be 5 1/3 as our final answer. So 5 1/3. All right, we're just going to practice a few of these, get the idea of this, okay? So the integration is 5 1/3. Area under the curve is about 5 1/3. All right, so into our second one here, we've got a picture to the right. And on this one, we're going to start out with our integration symbol. We're going to rewrite the equation, not the y equals part, just the stuff after the equals. And I'm going to write a dx, okay? And then I'm going to start looking for the upper and lower bound. So this is the lower bound. It is the far left number of our shaded area. This is the upper bound, a 1. And again, we can see that it is this equation for the horizontal. We're doing from the curve down to the x-axis. And then from left to right are my lower and upper bounds. Okay, so from here we just do our usual x to the 4th over 4 plus x to the 3rd over 3 plus 2x. Evaluate it between 1 and 0. So plugging in a 1 first, we'll have 1/4 plus 1/3 plus 2. And then we're going to subtract out 0. Okay, so let's see, if I turn these into 12ths, I will have 3 plus 4 of them plus an extra 2 as a whole number. So it looks like this is going to be 2 7/12 is our area under the curve from 0 to 1, and the curve is created by that x to the 3rd plus x squared plus 2. So this is the relationship between the equation, what you've been doing to evaluate, and then what the graph looks like. All right, so here's a super easy one, right? We've got a y equation that is just a horizontal line. So if our y equation is this horizontal line and we're finding the area between here and here, right, we're going to evaluate. The equation is going to be called 4 dx. My lower bound is going to be a -3 and a 7 for our upper bound. As I integrate this, this is going to become 4x, and I'm going to evaluate it between 7 and -3. Always the top number gets evaluated first. So this is going to be 28 minus -12. which if I add them together, that's going to be 40. Now, because this one is such an easy geometric shape, I could double check this one with the regular area formula. Since area is just base times height, what is our base? If we're going from -3 to 7, the base is 10, and our height was 4. So it does look like we have calculated it correctly, whether we use integration or just regular area. So some of these, if we actually know the area, especially if they're rectangular shapes, we can just double check them using area. Okay. All right, a couple more. So the next one, example 4, this one has an equation that is negative x, that's okay. So we're gonna evaluate negative x and a dx at the end, okay? And then we're gonna go look for upper and lower bound. So looks like the furthest left number we have is a +2, furthest right number we have is a 6. So that's what we're gonna be evaluating. Now again, remember, it's always going to go from the curve itself. This is the negative x graph and the x-axis, okay? Any idea what kind of answer we might get here? There's a trapezoid. We could check this with a trapezoid. Let's use antiderivatives. Let's use integration and see how we do. So this is going to be negative x squared over 2, and I'm going to evaluate it between 6 and 2. So when I plug in a 6, I'm going to square it first, then take the negative sign. So that's negative 36 over 2. Then a minus sign, and this time I'm going to get a negative 4 over 2. So this is negative 18 plus 2, which looks like it will be negative 16. So why am I getting a negative 16 for this one? Well, the reason is because it's below the x-axis. Now, when we're doing even just the general idea of area being base times height, right? Base is still positive, but now height is a negative amount. So we're doing a positive times a negative. That's going to give me a negative total, right? So could I check this with the formula for trapezoids? So the formula for trapezoids is area equals 1/2, and it is 1/2 base times base 1 plus base 2 times height. So here are our two bases. There's this base over on this side. There's this base over on this side. And our height is this amount. So let's go see. So if I do 1/2 and I add those together, that looks like it is a 2 plus 1, 2, 3, 4, 5, 6. The height would be this horizontal distance that is going from 2 to 6. That is a 4. So if I calculate this, this is going to be 1/2 of 8 times 4. That's also going to be a 16. Now I'm used to doing geometry areas, right? So I didn't even worry about pluses or minuses. So it's looking like that would be a 16. So the negative is just indicating that's below the x-axis, right? That I have a base that's positive and a height that just happens to be negative. Awesome. All right, our last one. This is a cubic function. Let's go try and see how this one works out. So on this one, we're going to start out with our integration symbol, 1/4 x to the third with a dx to end it. And let's go and take a look at what our lower and our upper bound is. So our lower bound is a -2, our upper bound is a 2. Right? Okay, and let's go and calculate this one. So if I do this one, it will be x to the 4th over 16, and it's going to get evaluated between 2 and -2. So if I put in a 2 to the 4th power, that's going to be 16. So I'm going to get 16 over 16 minus, if I put in a negative, it's going to also turn positive and be 16 over 16. So I'm going to get 1 minus 1, which is 0. Why would my integration be 0? Can you see? So if we look at the integral on the left-hand side of the screen, right, because it's below the x-axis, this would have given us a negative value for our integral. And this part over here, because it is all above the x-axis, it would be giving us a positive value for our integral. And they look like they're about the same amount, right? So if we add a negative value to a positive value, we should get 0. So that's how these work. All right, we'll see you next time.